So hello everyone, my name is Ishant Kumar and today we'll be solving this problem, teleporters. It is a greedy sorting problem, currently 1100 rated on Codeforces. So let's read the problem. Consider the points 0 all the way to n on the number line. There is a teleporter located on each of the points starting from 1 all the way to n. At point I, you can do the following: move left 1 unit, it costs 1 coin. Move right 1 unit, it costs 1 coin. Or third, use a teleporter at point I if it exists. It costs AI coins. As a result, you teleport to point 0. Once it's used a teleporter, you can't use it again. You have C coins and you start at point 0. What's the most number of teleporters you can use? So that was the problem. Let's see what the input is given for this problem. So as an input we'll be given t, which is going to be the number of test cases. After that they are going to give us c, n and c. N is the number of teleporters that we are going to get, and c will be the initial cost, initial coins that we are going to start with. After that we'll get all the values of the teleporters. So just to understand this problem in a easier way, just to make this problem a bit easier, let's change the name of teleporters. Let's use another name like door, which do the similar thing. So instead of teleporters, I'll be using the word door just to make this problem sound more easier. So let's look what the problem is actually trying to say. So just imagine that you're standing on a number line. Initially, you will be standing at the point 0 with C coins. Let's say C is some integer, and you can do three things. Firstly, either you can move left 1 unit, it will cost 1 coins. You can move right 1 unit, it will cost 1 coin. Or if there exists a door at the ith position, you can use the door and it will cost you AI points. Let's say we'll talk about it later in the when we take some test case, we'll get to know it better. And after using the door, you can just go back to the point 0 where you begin. And once you use one door, you cannot use it again. And using all these operations, we have to find the maximum number of doors that we can use. So let's take some test case and understand what's really going on in this problem and the logic for this problem. Let's take this test case here. So for this test case, where n is given as 8 and initially we are given 32 coins. So as mentioned in the problem that the number we are going to start from the number 0, but the indexing of the doors will be started from the number 1. I'll just show you that uh, the number line will be considered of 0 to all the way to n, but the doors are located from 1, so the indexing of the doors are started from 1 all the way to n. What does that mean is that we are given some doors here, so the indexing, since the indexing is starting from 1, we'll just index this as mentioned in this problem. This will be the index 1, second, third, fourth, fifth, sixth, seventh, and this will be indexed as 8. So in order to use a door, we have to calculate two things. First, the cost of that door and the cost of reaching that door. So let's calculate it for this array, that the number of doors that we have given. So in order to use the first door, which costs 100 coins, we have to move 1 unit right, since it is indexed as 1, and we have to move 1 unit right in order to use the door at the 100 door. So it will cost us a total of 101. 1 unit of moving to right, since it is mentioned here that moving to right also costs 1 unit, and moving to left or right it costs just 1 coin. So using the first door indexed at 1, it will cost us 101 coins, and the second door it will cost us 52 plus 2, which will be 54 coins. The third door will cost us 16 coins. The fourth door will cost us 10 coins. After that it will cost us 9 plus 5 14 coins. Then again it will cost us 10 coins. Then 100 plus 7, it will cost us 107 coins. And at last, which is indexed as 8, the eighth door will cost us 35 coins. So the total coins that we have to spend will be 35 plus 8, 43. So this is the cost for all the coins that are in for all the doors that are indexed here. So what we are going to do is that, since it is a sorting problem, we'll sort this cost of the doors. So let's first sort this. So after sorting, it should look like 10, 10, 14, then 16, then 43, 54, 101, and 107. So after sorting, this should look like this. Initially, we are beginning with 32 points, and we have to give the maximum number of doors that we can access. And this is the cost for using each door after the indexing, since it was mentioned in the question that the door at the ith position it costs AI coins. That's what we have calculated in the second line. And after calculating the cost for each door, we are going to sort that calculation. It will be easier. After that, since it is sorted from ascending order, we'll use the first door. It will cost us 10 coins, and we'll be left with 22 coins. After that, just remove this. So will be left with 22 coins. After that, we'll again be able to use the second door since it costs 10 coins. I'll mention it here. Cost of each door in coins. So after using the first door, we can still use the second door since we have 22 coins left after using the first door. We'll use the second door, which cost us 10 coins. We'll be left with 12 coins. But after that, after this second door, we cannot use this 14 costing like 14 coins, since we are only left with 12 coins. This door is like too expensive for us, so we'll be left with the number of doors will be 2. So for this test case, the maximum number of doors that we can open will be 2. So first of all, what we are going to do here, we have calculated the cost for opening each door. This is the cost for opening each door. Let's say the door at the first index cost 100 coins, second at 52 coins, third 13 coins, and so on. This is all the cost for all the doors. After that, after calculating all the cost, we are going to sort the cost of all the doors. After that, we'll just start using from left to right, since it is in sorted in ascending order, and see how many doors that we can open. And let's check the test answer for this test case. For this test case, we are given 2, which is the answer that we are getting. So this is going to be the logic for this problem. So let's look at the code this problem. Starting from here, initially we have taken t, which is going to be the number of test cases. After that, as an input, we are given n and c, the number of elements in the array, and this c will be the cost, initially cost that we are starting from. After that, I've declared a vector of cost, and inside this vector, I'm calculating all the cost that I've calculated earlier. But here, since I was talking earlier In all the languages, the indexing of the array it starts from 0, but the cost for all the indexing has started from 1. That's why I've initialized it, I'm adding 1 with I, since I is the number of cost of the door that we are getting, cost of reaching that door, and x will be the cost of the door that will be given in the problem. After calculating all the cost, I'm sorting the problem. After sorting, since we have to give the maximum number of doors that we can open, have an initialized count which will keep a track of the number of doors that I can open. So inside this loop, I've written a condition as long as the initial value that we have given, the initial number of coins that we have given is greater than the number of coins that we have calculated or equal to, it will be okay if it's equal to, is smaller than or equal to the initially given coins, will be good to go, will be good to open that door. If it is not, then we'll just break the array, and at that point we'll just see out or print the value of count that we have calculated. And after entering this, if we'll just do two things: decrement the value of cost that C coins that we have, since it will cost us cost I whatever we have calculated, and increment the value of those that we are going to open. So let's take the test case and check if this works. So this is going to be the problem number 1791 G dot exe. Let's take the test cases given in here. Let's compare the answers. So it is given 2 2 for the first two, and the 0 1, then two twos, after that 3. So answers are matching. So this is the core logic for this problem. We first have to calculate all the cost for each row. After that we have to sort. We do not have to sort it before calculating. That's the thing for this problem. And this was all for this problem. I hope you understood it well. Thank you.